That seems to work too. Light. You guys see okay? I'm jingling as I walk. If I put this down somewhere, yeah, I'll put it in my backpack. That way, if I leave it here, I have left everything here. And I'll have to come back and get it. That's perfect. That way I'll remember the backpack later. Welcome to ME 1800 again. Is anybody here that wasn't here last week? So you guys did not have a group then? So does your group accept one more? Perfect. Now you have a group. You guys too? All right. Anybody else over here? Did you guys figure out the system? So you shouldn't be at a table by yourself because there's no groups of one. Is the rest of you guys both? Oh, so you could join them. I really don't want more than, well, I really don't want more than 3 people in a group, but there aren't that many tables in the room. So I think 5 makes it work. Yeah. Say again? This is more than 5, right? You should find a different table that has less than 5 people in their group. Thanks. Okay. So while we're sorting around in groups and stuff like that, I think, all right, so this is shared. It should be shared online on the live video too. All right, so I updated the, so you guys will see this. I updated the little picture for ME 1800, so you'll know which one it is when you get there. And I actually posted the syllabus, although there's some stuff that's still filling in the syllabus. I just want to quickly go through a couple things here. If you go to the lab schedule, you'll see that it says to be determined. That's not entirely true. I actually know pretty much what it is, but the one that was already in this document was the one from A term, and we changed it for B term and C term. So I got to copy the right stuff in. So I actually know what the stuff is. It's just not copied in the document yet. If you go back here, there's also a lecture schedule. Can everybody hear me okay if I talk, or should I put the microphone thing on? Shout if you can't hear me, and then I'll shout so that you can hear me. Okay, lecture schedule, though. This stuff should be pretty good. Notice, January 25th. That's a Tuesday, no lecture. February 8th, also Tuesday, no lecture. 22nd, no lecture, and the, what is that? The 24th is the Thursday after that. There's no lecture that day because there's, what do they call it, a reading day? So read that day. Definitely read that day. But we got plenty of time to get everything else done. But so there's 3 Tuesdays that I won't be here for. And I thought about having you guys all come here and having like the TA show up and play a movie for you. But I thought that would be pretty lame. So I shuffled the topics into some other days. So we're covering all the same content. We just won't be live on those 3 days. What else we got? That's about it. So if we quickly look at the grading page here in the syllabus. So half the grade is based on doing the homework quizzes. I'm intending 5 of them. And they'll be due on, what day do you guys like to have quizzes due? Because you like Fridays? I really hate it when they're due like after the weekend. Because then some of you will think that you're going to spend some time on it on the weekend. And then you'll stress out about it all weekend without actually spending any extra time on it. and rush to get it finished, like right at the deadline. And I guarantee you that if you're emailing me at 11:30 on Sunday night to ask a question about the assignment, I'm not going to answer you. Even if I saw your email at 11:30 on Sunday night, I probably wouldn't answer it. But there's very little chance I would see it either. So, so those are not intended to be hard. Actually, there is nothing on the syllabus that is intended to be hard. Some of it requires practice. Some of it requires thinking. Now, I hope all of it requires some amount of thinking. And I guarantee you that I will not ask you a question on a quiz or a test that you cannot find the answer with Google. Pretty much impossible to ask a question that is not answerable somehow with Google. You may have to go to Google Scholar. You may have to look up some stuff. You may have to think. You may have to extrapolate on what somebody said there. And oftentimes, when you Google it, the result will be a YouTube video of me saying the answer. So just do the stuff. Oh, on those quizzes and stuff, how all should be set at unlimited attempts and grade the highest grade. I used to do unlimited attempts, but only grade the last one. And then people would like start it again to say, what was that question about? And then not finish it. And then, it was a pain in the ass because I had to go reset stuff and dig out people's grades. So unlimited attempts, only keep the highest score, which means you could game the system, right? You could just go put in answers to the questions to get, if that's how you want to spend your day, go for it. I think it's a waste of time. Copy the question, paste it in Google, and go from there rather than game the system. I want to set it up so that you can learn from it, not all that. So lab exercises are on completion. So lab exercises, 20% of the grade, it's based on completion. When you're doing the CAM exercises, so the CAM is the computer-aided manufacturing. It's the software we use to program the machines. When you're doing the CAM exercises, when you have finished a step, ask one of the PLAs to come over and look to see that you have finished it. They may ask you some questions about it. They may have you play the simulation of it, things like that. Then they'll check off that you completed it. Likewise, at the machine tools, when you're machining something, when you finish a step, we'll check off that you've completed it. Okay, so the lab 20% is about doing the stuff. I understand that some people may have issues that come up and they miss some of the labs and stuff. We'll work with each person individually on that. So if you can't go to all the labs, you'll probably still be able to do all the CAM assignments, but you may not do all the in-person stuff on time. We'll work with you on that. So final exam, lab exam, each 10%. The final exam is the only assignment in the class where I do not ask you to work with each other. I tell you to do that one on your own. You won't see any highly original questions on that final exam. All of the questions that you see there, you will have seen in a previous assignment, or at least a question very similar to it in the previous assignment. So if you've done all the other stuff, it should be really easy to do that final exam. And the lab final exam is in person, standing at the machine tool. You put your part in the machine, you select the program, you tell the machine where the part is, you operate the machine successfully without crashing it, and you get 100% on the exam. If you crash it, you automatically fail, but you're also asked to do it again. Because, it's like a driving test, right? Anybody fail their driving test first time through? What'd you do to fail the test? I ran a red light. Pulled out of a parking lot on the wrong side. And we were done with the test when I ran a red light. We were done with the test on the way back to the R&B place. And it was a town where I'd never driven in that town. We're at a stoplight. There was an obstruction blocking. You couldn't see the no turn on red sign. I asked the guy giving me the test, I said, can you make a right turn on red at this intersection? Because he's from the town. He knows. And he refused to answer, and I made the right turn on red, failed the exam. So turns out you can't, not there. Oh, well, But I get to take the test again, and I passed the second time. So yeah, lab exam. So there's 6 steps that are required steps when you're operating the machine tools. We'll go through this a bunch when we talk about labs. But basically, we check on a checklist. Did you do those 6 steps? They're all about the safety of you and the safety of the machine when you're doing the exercise. If you skip one of those 6 steps, I think we take off 25 points. So it's possible to get like a -50. But if you ask how to do one of those steps, we take off 5 points. So you could ask how to do all the steps and still pass the test. So it's about, do you know where the edge of your knowledge is, more than can you do everything on your own. All right. That's really all I wanted to talk about. You guys can look through the syllabus, stuff like that on your own. What are we talking about today? Anybody know? All right, what did we talk about last week? Anybody remember what we talked about last week? Yeah.
We were defining what manufacturing is.
Right, I said if you get one thing out of the class last Thursday, I said if you know what manufacturing is, then we've had a successful class. What is manufacturing? Yes.
It's the process of making some sort of item with intent to sell.
So, all right. So I said manufacturing was making stuff with the intent to sell it. And so that's the definition I use when I talk about manufacturing. And why is the intent to sell it important? Did we talk about that? Why?
Because if it's not, it's just a hobby.
It may be just a hobby, yeah. So it's what separates just making stuff from manufacturing. It's what makes manufacturing unique. And so we will talk a little bit about the selling it part very superficially throughout the class, but I want us to keep that in mind as we go through the class, because it's really about making stuff with a customer in mind. So it's a customer-centric activity. And so does anybody remember what we're supposed to talk about today then? Anybody check it out before we got here? Yeah.
Quality manufacturing.
So I said we're going to talk about quality in manufacturing today. Take just a second at your table in your group right now and decide what your table thinks quality in manufacturing means. Let's give it 30, 45 seconds, something like that. So just within your group, decide, what do you think quality in manufacturing means?
Unrelated. You have Discord.
Yes.
All right, so back corner over here. Did you guys come up with a group name, by the way? No? You did? What's your group name?
C and an S and a J.
CSJ. CSJ. Okay. Sounds like a freight company. Like the trains and stuff like that. Yeah, CSJ. All right, CSJ. What do you guys say quality manufacturing means?
Like the parts were like built to a certain specification.
All right, so CSJ says that the parts are built to a certain specification. You guys, what's your group? Got a name? You don't have to have a name. This table, no name table. What do you guys think quality in manufacturing is?
Yeah, so we basically just said, similar to what they said, the specification. I know that like a quality engineer kind of checks the quality of the product that was manufactured.
Okay.
So just making sure it fit the requirements.
So there's specifications, there's things like quality engineers. Over here, what do you guys think quality in manufacturing is?
Along the same lines of specification, if the product fell within the tolerances that you just
So it meets the specification and falls within the tolerances. He's going to go to sleep if I don't keep wiggling the mouse or plug it in. So if it meets the specifications, if it's within the tolerances, I heard you guys talking. I can't remember what you said though.
basically just want to keep a consistent and accurate product.
So you want it to be consistent and accurate. No major defects. All right, I got a little another little exercise for you. Get back over here. All right. So of these three car manufacturers, Mercedes, Chevrolet, and Kia, which one has the highest quality? So if you think, I'll have everybody stand up for a minute. If it's Mercedes, go over to this corner. If it's Chevrolet, go over to this corner. And if it's Kia, join me here in the middle. Or actually, I'll stay out of the voting, but hang out in the middle. So Mercedes back in the back over there, Chevy over here, Kia sort of in the mob in the middle here. So, all right, so I can see that we've sort of formed our blobs. So out of curiosity, why'd you guys pick Chevy as the highest quality? It's reliable.
I feel like it has to do with the price tag as well.
It has something to do with the price tag. Why'd you guys pick Kia?
Like the customers, Kia are less likely to complain.
So the Kia customers are less likely to complain. Why'd you guys pick Mercedes back here in the back? German engineering. It's a high-end vehicle. You have a Kia, so you didn't pick Kia. So of the Chevy people, who drives a GM product? Anybody? Both your parents do? Yeah. How about you guys? Anybody have a Kia? No, but there's Kia over here in the Mercedes pile. Anybody over here have a Mercedes? No. So I've actually had a Chevy, and I've had a Mercedes. I've never had a Kia. All right, you guys can all see the screen, right? So one of the screens. So according to a JD Power study in 2017, Kia was rated highest in quality. You guys can sit back down. What does this mean though? What does this graph actually mean? Yeah.
out of time after ownership, after getting the car, how many problems did people have with it?
Yeah, so the way they do this study, and I've got similar understanding of how they do this. The way they do this study is they actually collect information from the manufacturer. And they're collecting information from the manufacturer's service department. That kind of makes, so like the individual dealerships and the service departments. And it's, so did you notice, by the way, that Mercedes is more than 100? So it's not percentage. It's not like it has more than 100% of problems, right? But it's how many complaints per 100 vehicles sold, right? So if I asked you to choose again, who would still go to the same spot? Who would change spots? Of the people that would change spots, would you jump to Kia? You've got your hand up.
You said it was based on the complaints of customers, but I believe I remember being told that Kia customers were less likely to complain.
I heard somebody say that Kia customers were less likely to complain. I would like to have you think of the fact that maybe this data is flawed, right? What does it actually tell us? What it tells us is that these guys at JD Power asked a question, and the way they got their answer was by finding out how many people complained about their car. I would say that possibly the customer of the Kia is less likely to complain about a small problem than the customer of the Mercedes. So I don't know that it's true, right? I haven't psychoanalyzed all the people, but I think it's possible. But it really gets us to our question of what is quality in manufacturing. Because I do think that Kia has hit that quality bar here. Because what is quality in manufacturing really? You guys, so we put up words like specifications, right? So meeting specifications. We said that we meet the tolerances. What's a tolerance in manufacturing? What, I mean, I do a whole lecture about tolerances, and I got a video clip in there from what's the Finding Nemo. Right? See, who's seen Finding Nemo? When he first goes to school, and they're all swimming around getting ready for the instructor to come in, and one of the little fish comes over and he's like, "I'm H2O intolerant." So I was start my tolerances lecture with the little clip there of H2O intolerant. I thought it was funny. Maybe it's actually not funny. It is funny when you guys laugh at me, I guess. So quality in manufacturing is about meeting those specifications. It's about hitting the tolerances. And my question was, what's tolerancing in manufacturing? And you had your hand up.
Oh yeah. If the amount of dimension can be off, so usually like 3,000 of an inch, the amount of dimension can be off and still have the part work.
Right. And the designer specifies the tolerances. So the tolerances are basically on each dimension, on each thing that's specified by the designer. It's how much is the manufacturer allowed to screw up and still have it be a good part. So that's what the tolerances are. So it's, is it better to have broad tolerances, wide tolerances, or tight tolerances? So stand up if you think it's better to have broad tolerances. We're going to all get a workout. So loose, we call these loose tolerances or broad tolerances. It's just like go ahead. If you're the designer, you get to choose what the tolerances are. I mean, you may be driven in your choice of what the tolerances are by needing the thing to work, right? But you should choose tolerances that allow your thing to work. Is it better to have loose tolerances or tight tolerances? So stand up if you're like loose tolerances, which means there's a bigger target to hit if you're for the manufacturer. So it's about a third of you had a question?
Yeah,
language no one cares.
Okay, so it depends on what the consumer, you guys can sit back down. It depends on what the consumer wants, right? I would argue that you want the broadest tolerance, the loosest tolerance that meets the customer need. And if you have the loosest tolerance that meets the customer need, there's more likely that the manufacturer is going to be able to hit that tolerance. And the easier it is for the manufacturer to hit that tolerance, the cheaper the part's going to be. It's also, I would say, the broader the tolerance, because we almost never make anything that's useful that has one part, right? Usually the things that we use are assemblies of parts that fit together. And so if all those parts have broad tolerances and it still functions, then it's more likely that our things are going to work, not just be cheaper, but they're more likely to work. So we like to have those broad tolerances. We said, so we talked about accuracy. Anybody know what I wrote here? Consistency. So when I did my PhD work, I did a lot of measurement, things like that. A lot of people do a lot of measurement when they do a PhD, but my PhD was actually about measurement. And one of the things we looked at was repeatability, and so reproducibility and repeatability of gauges, so the measurement tools. And so that's really about the consistency there, but it's kind of funny that I can't write very consistently. But we talked about accuracy and consistency here. And I would, instead of consistency, I might call that repeatability. And it's, so there's two things that we look at with this repeatability here, is how the same are the individual parts. Does that make sense? So are all the parts the same as each other? And then how the same are our measurements of the individual parts? Because we can have uncertainty in our measurement also, right? So that's where we have the gauge repeatability and reproducibility. So that breaks down the difference between the measurements and the parts themselves. What is accuracy? Yeah. Right. So the accuracy is how closely you are to the true value. And so the parts themselves, I suppose the parts could be accurate, right? But usually when we talk about accuracy, we're talking about the measurement of the parts. But all right, so why do I say, so J.D. Power says Kia is the highest quality out of these. And I said that I think J.D. Power got it right. But we do have to think about that bias that maybe those Kia customers are less likely to complain. Why do I say that I think J.D. Power got it right, even though I've never owned a Kia? Yeah.
They sort of built their brand on producing cheap, reliable cars.
Right, because they were giving the customer what the customer expected. Right, when Mercedes got more complaints, they got more than one complaint per 100 cars, or per each car for 100 cars, is because the customer had a higher expectation. Customer had a different expectation. The customer was more likely to complain. Kia gets less. Now, I have no idea about the material defects of the two different cars. It's possible that Kia also had fewer material defects. That's not what this study shows. What the study shows is about the customer complaints about it. But what Kia was able to do is they were able to meet their customer expectation. And so if you look at this in the in that sense, quality in anything, but quality in manufacturing is really, are you able to give the customer what the customer expects? I like to say give the customer what the customer needs, but that's slightly different, possibly, from what they expect. So let's move on here. So all right, so we talked about what is quality, and is quality just in the eye of the beholder? So giving the customer what they expect is really like saying beauty's in the eye of the beholder, quality's in the eye of the beholder. Is that true? Go ahead.
I tend to think that I think there are some metrics that measure how close to those goals you are. Yeah.
All right, so you think that it shouldn't be, because there should be a measurement involved,
There should be
some objective measurement. What do you say in the back?
I would say for people, you can measure it and not measurable. So then you have, like, in the car, see material quality, right? Some people say measure your history with material quality. But if the car breaks, then there's clearly a problem with it. If you have a car with bad material quality but doesn't break, is that, you know what I mean?
Okay. Oh, so there's different levels of quality based on functional measures.
I was going to say there's multiple. There's what's in the eye of the beholder. There's also what's like you can measure. Like if you can measure if a certain aluminum is better than a different kind. But if you look at the quality of manufacturing, it's dependent on the person buying it. If someone buying a Kia might be thinking, oh, I'm only going to this will last me 4 or 5 years. I'm not going to have too many problems. The person trying to do Mercedes is saying, I want 7, 8 years. And, you know, Kia starts to break down after 4 or 5 years. It's not a problem. Mercedes starts to break down 4 or 5 years. It's not what they expect.
Okay, so it really is up to what the customer expectation is. But the customer may expect you to measure things. So I like the idea that we brought up this measurement in quality, but really it's about the customer. Now, so we talk about quality in manufacturing. It turns out that there's so somebody mentioned quality engineers. Who was it that mentioned you did, right? You talked. Do you have experience with a quality engineer? Do you know somebody that's a quality engineer? No. Because I know I did. I was doing this lecture once, and somebody for their summer job or for their internship, they'd actually worked in the quality department at a company. Now they were currently working. They were working part-time as a quality engineer at a company at the time. And so, all right, so we could graduate from WPI and we could get a job as a quality engineer. There's no major at WPI that's called quality engineering that I know of, although did you guys know that it's possible to invent your own major here? You can create your own degree, and if you get a faculty member to say yes, they'll advise that, and you get a department head to say yes, that's appropriate, then you're golden. You can make your own degree. I've seen people do it. I actually have a friend who got a bachelor's of arts in engineering here at WPI. Did you know that was possible? There's been 2 given out. Actually, I know both people. They were classmates of each other. Huh. Anyway, they're both working engineers now, but they got bachelors of arts in engineering here. Okay, so what is quality? So quality engineers, who's a member of a professional society here? Anybody has joined any professional societies since they became WPI students? You got your hand sort of up? You think you did?
Yeah.
So there's two kind of who's a mechanical engineering major here? Never mind. Who's not a mechanical engineering major here? Okay, so it's a good mix. So for mechanical engineers, there's ASME, which used to stand for the American Society of Mechanical Engineering. Now it just stands for ASME. And there's SME, which used to stand for Society of Manufacturing Engineers, but now it's just SME. There's also ASM, which used to stand for American Society of Materials, but now it's just ASM. The reason all of these societies got rid of the American at the beginning of their name is they decided they wanted to be international societies, so they could have their annual meetings in places like China and Singapore and places like that. So they got tired of, I guess, going to Puerto Rico and Hawaii for their annual meetings. But these societies. So there's also ASQ, which is the Society for Quality Engineers, and ASQ defines things like what is quality in manufacturing. They have trainings. They got all kinds of stuff. They actually say that quality is a subjective term for which each person or sector has its own definition. The Society for Quality Engineers says, yeah, quality is subjective. It's in the eye of the beholder. And they talk about characteristics of a product that bear on its ability to satisfy the customer need. So that's did the customer expect to get 5 good years out of this car and then have it break down? Or did they expect to get 15 good years out of this car and have it break down, right? Did you meet the customer need? And a product or service that's free of deficiencies. So no extra charge for deficiencies. That's not the kind of free they mean. All right. But what's quality in manufacturing, though? It's giving the customer what the customer needs and expects. So if we're doing, well, all right, so there's a couple different kinds of manufacturing we could be talking about, right? So we said that manufacturing is making stuff that we intend to sell to a customer. What kind of stuff do customers buy? You guys are customers, right? What kind of stuff do you buy? Yeah. Clothing, shoes. Anybody ever buy a car? A couple people have bought a car. Anybody ever buy an airplane? It's possible. No, you bought an airplane before? Little one? Anybody ever buy a game of some sort? An electronic appliance of some sort? So those are the things that you as consumers have purchased. So those are consumer products. Is that a good label for them? And there's businesses that sell, they call it B2C. It's business to consumer kind of products. This is B2C kind of products. And so there's manufacturing that happens there. Right? Those things that you purchased were made. A lot of them were assembled. You're the one that was assembling robots, right? Right? So you assembled that robot before you used it. So there was assembly, there was manufacturing, fabrication, all these things happened for those products before they got to you. And you probably bought it at a retail location. More than likely. So the companies that did that final assembly, the people that put those things together and then distributed them to those retail locations, either through a distributor or maybe you bought it direct from a website or something like that, direct from the manufacturer. Those are OEM manufacturers, so original equipment manufacturers. That's just what we call them. They make the thing that somebody buys. You hear about the large OEMs like Ford and General Motors and Kia and Toyota and all those big companies, right? They're making cars. There's also B2b manufacturing companies, so business to business manufacturing companies. And they typically are making the parts that go in those things that the OEMs are using to put together the final products, right? So you may... So if you're buying a car, if you're buying that Chevy, General Motors does not make all the parts that go in that car. They buy parts from thousands of different companies all around the world that are making components that are going to go in that car. Most manufacturing actually happens at those other companies, not at the OEMs, but at the smaller companies that are bringing parts to the OEMs then assembling it and sending it out to you guys as the customers. So most manufacturing is happening at these smaller manufacturing companies. Actually, in the United States, I don't know about the world, in the United States, most manufacturing happens at companies with 50 or fewer employees. And it's something like 20% of the GDP of the United States. It's happening at companies with fewer than 50 employees. I know in Massachusetts, it's mostly companies with fewer than 20 employees. So a lot of this, and so a lot of you will end up working at companies like that, and you'll be in a position to do quality engineering, whether you want to or not, because quality is giving the customer what the customer needs. So how do we know what the customer needs? Yep. They tell us. That's the first step. We know what the customer needs because they've told us what they need. How do they tell us? Yep. No, not so. The end customer. So if we're talking about a consumer product, the designers, the people that are going to bring that product to us, may do some surveys to determine what we as end customers need. But now if we're thinking as the manufacturer at this, call it a tier 2 or tier 3 manufacturing facility, our customer is actually just another manufacturing company. So they're very specific with what they tell us. No? Yes. You guys can't see me smiling over, or maybe you can. Who can tell I'm smiling under the mask? You can tell? Did you hear me chuckle? Yeah. So you said usually the company that we're selling to, so our customer, usually you said they have like engineers? I think that you actually said like engineers. Yeah. And as a person who actually owns a company that sells to companies like that, I would also say that, yeah, they have like engineers. Go ahead. Yeah. Does your mom complain about the quality of the like engineering? Okay. Yeah. So one of the things, and that's actually my goal here, partly in this class, but just the reason that I work at WPI in general is I'd like to be able to make engineers. You guys are all engineers, right? Ish. You guys are all engineers. I'd like to be able to make engineers and understand how things are made so that when you design things, who likes to design stuff? Who became an engineer because they like to design stuff? And they have ideas that go through their head. And they like to design them. Yeah, that was me. I became an engineer because I was always thinking of stuff and I want to be able to design it. I remember being a kid and like designing a helicopter because I wanted to build it and go fly around in it. So we become an engineer because we like to design stuff. So I'd like you guys to all be able to design stuff that can be made. So often, but let's just assume that they have engineers. And they have engineers that have made a design. They send us the design, and that design will include, who's had a design class here at WPI? You've had it. So what do they teach you to do in the design class here?
I guess like determine what you want.
So we determine what we want, yeah. But what's the product of design? What does designing give us? Yes. We get dimensions and specifications. Where do we list the dimensions? Yeah. In the design, but what's the specific part of the design? Yeah. So we'll make a print or a drawing of the thing. Often we'll do solid models, right? So in a lot of the design, so ES 1310. Who's had ES 1310? And so you guys use SolidWorks there now? Yep. So you learned how to use SolidWorks, and SolidWorks is all about making that solid model. The drawing part of it is sort of an afterthought, even, is it? Or like a secondary thing. When you're designing in SolidWorks, you're typically not creating drawings and then meshing them together into a solid. You're creating a solid in the software, and then from the solid, you're making projections and different views for those drawings, right? And so you put those dimensions on the drawings because it's easy to see, right? It's a way of conveying the information. So we make our solid models, we make our drawings, we may make specification sheets, so spec sheets we'll call those. They may just be notes on the drawing where you say this material, this hardness, this heat treating of these things. And so that's the designer's job, is to determine what they need in order to meet the specification, or to meet the customer's needs. So us as the end customers, the consumers, we don't, I would be very dissatisfied if this pen sort of was sweat soluble. And as my hand was sweating as I was holding this marker, if it dissolved the outside casing of the pen, and then I was just holding on to the felt that was ink impregnated, I'd be very disappointed as an end customer, right? So the designer of this had to know to specify a material for the outer casing that was not going to dissolve if it got touched by like sweaty hands. So the designer figures all those things out. They give us, the manufacturers, those specifications. So we've got our specifications. Our designer has sent us the specifications. Often we've entered into a contract with them to create the thing that they specified and deliver it at a certain time as the manufacturer. How do we know that we have quality? So giving the customer what they asked for, that is quality. So how do we know that we have quality as a manufacturer? Yep. They continue to buy our product. We know we have had quality in the past if they reorder in the future. I agree. In fact, we know we don't have quality when they refuse to pay for it. How do we know? So before it gets to that point of them refusing to pay for it or not reordering, how do we know we have quality? We could perform tests on the product. What kind of tests? Yep. You could test its physical properties. So I could hold it in my hand and see if it dissolves while I don't know, go work out, right? Maybe I could make a pull-up bar out of it, see if it dissolves. It's more of a pull down here, huh? It's a lot easier to do pull downs than pull ups. How do we know that we have quality? Yes. We use gauges. Right, so we know we have quality because we measure and we compare our measurements with the specifications that the designer gave us. Yep. So customer surveys, and that works especially well if you're the OEM and you're sending stuff out. So we would like to have our customers reorder and buy more stuff from us if we're the OEM. But we can also ask them, hey, you got our thing. Did you like it? Did it meet your needs? So as an OEM, I'm thinking more as the sub-tier manufacturer that's supplying parts to the OEMs. Yep. So you can. In fact, so if you look at the syllabus on the, I want to say Blackboard. We haven't used Blackboard here in like 10 years. The Canvas site. If you look at the syllabus on the Canvas site, there is a link. There should be a link to a reading where we're going to talk about you doing comparative analysis to control quality. So you basically, you make one and you say, all right, this one was good because we had good customer feedback from this one. And then we make another one and we compare it to this one that we had good customer feedback for. And that's a very common thing to do, especially to control manufacturing processes, right? So when you're in production, you take the next one off, and if it looks like the last one, it's probably a good part. And if it doesn't look like the last one, it's probably a bad part, right? So tomorrow we're back here, same time. And I'm going to talk about the group project. It's going to be one group project for the whole term. We're going to start on it tomorrow. And we're going to continue to talk about quality and manufacturing tomorrow and Thursday. And that's the quality week. Oh, anyway, there's a reading. There's a link to a reading about quality in the syllabus. Tomorrow we're back here, same bat time, same bat channel.